So problem number 23. A ship leaves a port on a bearing of 43 degrees. So let's represent everything. So this is the north, this is the east, this is the south. Basically angles, deviation. So let's represent the port being at the center. This is the port. So the deviation from the north is about 23 degrees. No, 43 degrees. Yes, 43 degrees. So it deviates from the north by 43 degrees, and it travels about 11.8 miles. So it traveled that distance from the port, 11.8 miles, and then it turns due east, meaning that it turns to the right, straight up right. So it goes to the right on the east side, goes and it travels 5.7 miles. So 5.7 miles. So the question is, how far is the ship? This is the ship here. How far is the ship from the port? So what's the distance between the port and the ship? There's no distance. Okay, so how do we find the different angles? How do we do that? So first of all, what we notice that this is 43 degree, right? And then if I continue this picture like that, if I continue here, I notice that this is like a right triangle here, like that, and this is a right angle, right? This is a right angle, and I need to find this angle that is here. My ultimate goal is to find this distance that is here. I have two sides. I need the angle that is here so that I can use the law of cosine. So in order for me to find the angle that is here, I need to first find the angle that is here. And how do I find that angle that is here? I can use the angle that is here. So this is 43 degrees, this is 90 degrees because that's like a right angle, and we don't know this one. We know that in a triangle the sum of all the three sides is equal to 180 degrees. So in other words, 90 degrees that is here plus the 43 degree that is here plus the unknown, let's call it x, that is here is equal to 180 degrees. So x will be equal to 180 degree minus the 90 degree minus the 43 degrees. So x will be equals to 47 degree. So the angle that is here is 47 degree. Now this angle form an horizontal. This side here is like an horizontal angle, and an horizontal angle is just 180 degrees. So the entirety, this angle here is 180 degrees. But I'm only looking for a very small portion, meaning that I'm looking for this one here, this angle that is here. Alright, and I need this one here. I know that from here to here is 47, and the entire thing is 180 degree. So I do 180 degree the entirety minus the small portion 47 to find this one here. So I do 180 degree minus the 47 degree, and that is equal to 133 degrees. So the angle that is here is 133 degrees. Okay, now I have two sides, 11.8 and 5.7, and I have an angle. I can find the length that is here using the law of cosine. So let's call this distance here, let's call it d. So d is equal to, based on the law of cosine, square root of the side that is here, which is equal to 11.8, 11.8 plus this other side that is here, 5.7, I square that, minus 2 times 11.8, 5.7 cosine of the 133 degree, right here. So the distance will be equal to and let's say to round it to the nearest tenth, I think. So I use my calculator. So 11.8, I always start with whatever is inside. 5.7 minus 2, 11.8, 5.7 cosine of 133 equals to that, and I take the square root of my answer equals to that, and then I'll round it to the nearest tenth equals to this, 16.2 mile. Now that I finish it, this is the distance d. Now they're asking to find what is the bearing from the port. So the ship is right here, right? So the question is, how is it deviated from the north? Given that I'm at the port, what's the deviation from the north from here to here? That's what they're asking. So for me to find that angle, I need to find that small portion that is here. I already know the other part, which is 43, but I need to find this one that is here, the small portion. So I can look at this shape as a triangle by itself. So I can redraw the picture like that as a triangle on its own, like that. I will try to do something that is approximately similar. Okay. So I'm looking for this small portion. Let's call this small portion theta. This one is 5.7. This is my ship right here, and this length here is 11.8, and this distance I just found it was 16.2. So based on the law of sine, I have one angle here, I have another angle here, which is 133. Based on the law of sine, sine of theta divided by 5.7 is equal to the sine of 133 divided by 16.2. So I can write it down. So sine of theta that is here, based on the law of sine, divided by 5.7 is equal to the sine of 133 times 16.2. So sine of theta will be equal to 5 sine of 133 16.2 multiplied by 5.7, and then I take this, I'm looking for theta, so I take the sine inverse of all of this. So theta will be equal to the sine inverse of sine of 133 divided by 16.2 times 5.7, like that. I take the sine inverse of this, so let me do that manually with the calculator. So sine of 133 times 5.7 divided by 16.2 equals to this, and then I take the sine inverse of my answer. I get 14.911. Now this is the angle theta, 14.91. Let me round it to the nearest 10 because that's what they want as the final answer. 14.9. So this is just, theta is just 14.9. So 14.9. So that small portion of angle that is here is 14.9. So the bearing, that means the bearing from the port from here to here will be 43 plus the 14.9. So the bearing equals to 43 degrees plus 14.9, which is equal to 57.9. And that's my final answer. So that's the bearing. So that's how you solve this kind of problem.